There are two constructors. How do we know that? Because these two have the same name as the class, right? And what else is special about them? They look like methods, but what? What's missing? The return type. So these 5 methods have a return type that goes right before the name. You have to have those two things, the return type and the name, to define a method. A constructor has to match the name of the class and not have a return type, because it can never return anything. Okay? So that would be a 2 for that one. Instance variables, there are 3 up here. Okay? These all count as instance variables. My A, my B, and max are all instance variables. Listen to me. The whole point to this class is to create objects, to find what an exam object is. Okay? And so exam object is supposed to store 3 things. A my A, my B, whatever those might be, and a max. Now, okay, I'm not going to change this. I think I'll change it for next year. The max really, in fact, I'm going to change this now. Don't change it. I'm going to change it back. I use the term instance variables here. Not every variable is going to be an instance variable. Some are not. Okay. If they're static, if you ever see the word static, it means it's associated. It's not associated with an object. It has nothing to do with a particular object. It kind of has to do with all objects, if you will. And so, basically, the main point right now is that if it doesn't say static, it is an instance variable. Another name for instance variables is non-static variables. In fact, I would write that here on your paper. Because if you're looking things up on the internet, that's terminology you'll see. Some people don't use the term instance variable, but they call them non-static variables. Okay? So now, the variable max is in all caps because it's set to be final. Which, what do you think final means? It means the value you see is the final value. It's a constant. You can't change it. Okay? So of the 3 instance variables, one of them is a constant variable because it says final. Right here where it says final, that means the value that it is given there is the final value it can never have. Unlike the other 2, like here, it gives my A, my B both a value of 100. Here it gives my A, whatever value you gave it, you know, this parameter is going to store whatever value you type in or you give it. And so, but you can change it. How do I know you can change it? Because down here, you have a set method that allows you to change it. So these are normal variables that they can be given one value, then a different value, then a different value. You can't do that with final variables. Okay? Now, access methods versus modifier methods. Hold on 1 second. Try to take this. Look, first of all, we said there's 5 methods in the class. These 2 are called setter methods. What do? They store new data into the object, either in my A or my B. They change the state of the object, we say. What does this object store? 3 things, really. 2 ints here, and then max, which is always 100. What I'm saying is, if a method changes what the object stores, we call it a modifier method. Okay? Do get A and get B change what the object stores? No. They do access one of the variables, one of the instance variables. So we call those accessor methods. So we for sure have 2 modifier and 2 accessor. What about the string method? How do you classify that one? An accessor or modifier? Well, it doesn't do anything directly, but what does it call? It calls the getter methods, which are accessor methods. So it does indirectly access the variables. So it counts as an accessor method. So you should have had 2 modifier methods, the setter methods, and 3 accessor methods, the getter methods, and the string method. By the way, listen, about the string method. Generally speaking, if you make a class of your own, you should give it a string method. And what it should generally do is what this one does. It shows the current state of the object. And so if you print an object, ever, Java automatically calls the string method, so you can see what the variables are storing at that moment in time. And then if you change things later on, you can print it again, see what it's storing then. And one thing that's helpful is sometimes what you screw up when you make this stuff is you screw up this stuff. You screw up what is supposed to get the data into the object. And the way you know you screwed it up is by printing the object, and you see, well, either it has the data you meant to put in there, or it doesn't. By the way, these first 2, they were automatically set to 0 by Java. So I'm saying, let's say you made an object, you thought you said it to store, I don't know, 50 and a 70. But when you print it, you see it storing a 0 and a 0. That's your clue that you screwed up. You didn't actually make it store what you intended. And so where do you look for an error? Well, in your constructor, or maybe in your setter method. And just for the record, I told you yesterday, the most common mistake on these things is to do exactly this, to get that backwards. And that's how you can tell that's where your error is, by using the string method. Now, what's next? Now, we talked about it yesterday, I mentioned the word encapsulation. Once again, your variables up here, the instance variables, should always be private. The constructors and methods should always be public. Or almost always. Occasionally we'll have a private method, but that's rare. This is a general rule. And once again, this is not how Java is coded. You can make these whatever you want according to Java. You can make these, they can all be private or public. It'll compile either way. But this is how object-oriented programming is done, generally speaking. That's how we'll always do it. So, instance variables should be private. Constructors and methods should be public. Now, if you look at this, now first of all, let's just go through like this one. What's wrong with this one? Right, it's missing the new keyword, perfect. What's wrong with A? There's no parentheses, which means Java is going to think that's a variable name. Okay? Now, which of these is correct then, C or D? C, and because you're trying to create an exam object, and so that one's correct. So this one's bad. Don't select that one. Okay? Now, the next one, first of all, B is wrong because it's missing the new keyword, and A is wrong because for the same reason we said. But these both look like they have the right syntax. But one of them is wrong, one of them is right. How do you tell the difference? Can we explain how we know which is valid? And you have to look at the class to answer that question. And by the way, I'm serious. 8, you didn't have to look at the exam class to know that C is the only valid answer. But for 9, you have to look at the class to know. And so which one is it? Which one's valid? The one that takes this one. It has 2 arguments. Once again, the numbers you plug in to a function are called the arguments. The 90 and 99 would be copied into these 2 parameters, A and B. And it works because, yes, that is the correct answer, because we have a constructor that takes no parameters. We have a constructor that takes 2 instance parameters. There is no constructor defined here that takes 1 int. It doesn't exist. And once again, you have to have the idea that the compiler is going to try to understand what you intend. It's trying to understand what you want, right? You say you want to create an exam object. You gave it these 2 things. It's going to look for some code named that way that matches. And so, yeah, this one, there is no such constructor. That's why that one's wrong. And so that's how Java matches things up. It looks at the name and then the number and type of parameters. Now, one more term. I haven't, well, this one I'll just tell you. It is a return method. That is the answer. Okay? Number 10 is the return method. Look up here. Of the 5 methods, which ones, or how many are return methods? I mean, the string method's one of them. Yeah. These 2 return ints. This one returns a string. So those are your 3 return methods. These 2 are not return methods because they don't return anything. Now, remember what I said about the string method? That the intent is to show the current state of the object. Now look at number 2 first. So what does a B object store? Just an int. And this one's a really stupid little class. I say that way because all a B object can ever store is 0, which means what is the purpose? Nothing other than try to make a point to you. But so when you print right here, a new B object is created. That B object will be in memory somewhere with an X variable that stores 0. When you print an object, Java automatically calls that object to string method. So what you have here, and I would write this in, is the same as if it said runner.toString. So write that in. That happens automatically. You can put that if you want. I mean, like when you write your code, you can say, print line runner.toString. We don't usually, because it's automatic. Okay. Well, in this case, on number 2, the output will be 0. Yes, because it's storing a 0. Let me go back to number 1. Remember what I just said. Java is automatically going to call this object's toString method, but we don't see a toString method. But the fact is, it has one. Hold on 1 second. By the way, I told you I'll have a new article out there every day. Actually, I'm keeping the one out there from yesterday. Google is an ad company. It's true. You should read that article and be aware of that. And most of those big companies, they go through all your data. So like Gmail, they scan everything you do in Gmail, and they target their ads at you based on what you store in their Google Drive and what you send in your emails. So anyway, just be aware. What was I doing? Oh yeah, Java API object. There is an object class. Let me bring it up, and it has all these methods. The main ones you need to know about are the equals method and the toString method. And look at this. If you click on the toString method, this is the normal default behavior. It gets you the class name, then an @ symbol, and then something called a hash code, which you don't have to worry about what a hash code is. I'm just saying every object has a toString method, always, that it inherits from the object class that behaves the way I just showed you. We don't like that. You should always give it your own toString method, okay? But it always works. So right here, we're going to call the toString method, just like before. In fact, I'll type that in again. I'll write that down. That happens. And now what is the class name here? A. So I said the default toString method will show the class name, A, an @ symbol, and then something called a hash code, which I'm just going to make up something random. A hexadecimal number, which it's base 16 number, that probably is meaningless to you still. You can use your digits. This is weird. You don't just have 10 digits, 0 through 9. You have 16 digits, 0 through F, 0 through 15. And so that's a hexadecimal number. It might as well be a random number. It's not technically, but it might as well be. That is not very useful output, is it? No. Which is why we don't like to use the default toString method. We like to make our own. By the way, just real quick, remember what I said. The normal purpose of the toString method is show what the object stores. Okay? So when you make your own, that's what it should do. It should show what the variables are storing. If you think about it, if that's the case, then why do they make the default work this way? Because remember, this is the object class, which is the root of all objects. It's like this, the parent of all other objects, and it doesn't store anything. And also, it has no idea what any other class will store. I mean, think about it. A string object stores one thing. These objects store a different thing. An array is an object. It stores something else. They're all different. And so it couldn't be set up that way. They set it up this way just to guarantee that every class would have a toString method. Because it's an object class, every object has a toString method. Every object has an equals method. And they have everything else in here as well. All right. This one. First of all, how many constructors are in this class? 2, actually, right? 2. There's the one that takes no parameters. It's called the no argument constructor or the default constructor. And then the one that takes 1 int as a parameter. And then that's it. And then how many methods are in this class? How many methods? 1, the toString method. And how many instance variables? Just 1, x, which is an int. So it's a very bare bones class. It has one instance variable, and so it just stores a number still. At least this time, it can store something other than 0. It's better than the last one, at least. So in our case, it's going to create a C object. When it creates a C object, it gives an x variable, and then it gives it that x variable a value of 56. Once again, technically, listen carefully. The 56 is the argument here. It gets copied into this parameter. We don't want it there. This parameter is short-lived. It only exists inside the constructor. We want it in the instance variable, which is what this does. It copies the 56 out of num into x, which is what the constructor should do. And so when you print the object, what method gets called? The toString method, which is going to show the x value. So what is the answer? There you go. That's the basics of how you create objects, get them to store the data you want, and how you see what data they're storing.